Hello world, I hope you're doing right. If you're like me, you kind of feel like Julie Andrews in The Sound of Music. You know, you feel like singing. The world, the hills are alive with the sound of music. I hope that's how you feel. Yeah, physics makes me very excited. It's very stimulating, isn't it? All right, our subject for today is the circuits in IGCSE physics. Of course, why is circuits important? Well, we use circuits all the time, don't we? When you want to charge your cell phone, as an example, right? Charging your cell phone. If you want to play Xbox, that's really important, right? Life-changing stuff there. Maybe examples, even some cars will use complete circuits, right? So circuits in everyday life, even turning on a light bulb is an example, right? So if you have a complete circuit, you generally are using circuit. Like I said, they're part of everyday life for us. So let's discuss some aspects having to do with circuits. We're going to discuss voltage, current, resistance, and some of the related formulae. All right, discuss voltage, current, resistance, and some of the related formulae. Let's discuss voltage first. Often people don't always know the difference between these expressions and what they mean. So let's discuss voltage first. If you have a cell, right, or a battery, many cells make a battery, right? But let's just draw a cell. The short side, as you would know, is the negative side, right? This side is negative. And the long side is the positive side, isn't it? So, as we should know, current flows from the positive side, but in truth, electrons are flowing from the negative side. But we say current is flowing from the positive side. Current flowing from the positive side. And let's say I have two resistors in my circuit like that. If my cell has, say, 30 volts, so the voltage in your cell or your battery is normally known as the EMF, right? So if my voltage has a voltage, my cell has a voltage of 30 volts, my resistors, for example, let's call this resistor A and resistor B. Resistor A, for example, might get 10 volts, in which case resistor B will get 20 volts, right? So I like to think of the voltage as a bit of a family, isn't it? It's a bit of a family. And I'm focusing on what I call the main circuit. And in the circuit, you have 10 volts and 20 volts, which of course adds up to 30. So let's say, for example, the cell, which I like to compare to a parent, really, has 40 volts. And this parent has 3 children this time, right? The resistors are like children, right? Resistors like children. And if this child gets 10 volts, and maybe this child gets 15 volts, and of course that leaves child C to get how many volts, right? To also get 15 volts, because these 3 children will inherit what they get from their parent, right? I hope that makes perfect sense, right? So voltage is sort of like a family. And of course, now the question is, how do you determine what each child gets? Now that is an interesting question. So let's go back to a situation where there are 2 children, 2 resistors, right? This parent, say, has 20 volts, right? And child A has 5 ohms, and child B has 15 ohms. Which child gets the most amount of voltage? And the truth of the matter that it's in proportion to the amount of resistance, right? So basically, more resistance results in more voltage. I grew up being a second child in the home and the younger child. So every time, with my mom and dad, if we had to share a packet of sweets or, we had to share money, my mom and dad were often like, well, you're the younger child. You should accept that you should get less. I'm not sure that's necessarily fair, but that's sort of how it worked in our home. So the child with the bigger resistance gets more voltage, and the child with the smaller resistance will get less voltage. I hope that makes perfect sense to you, right? So for example, how much does he get? Well, what you would then do is you'd add the total resistance. Total resistance is 20. So you'd say for child B, for resistor B, he gets 15 ohms. That's what he has, right? Over the total, which is 20 ohms, of course, multiplied by the voltage being shared from the parent, which is 20 volts. And therefore, you have 15 volts for resistor B. For resistor A, he had 5 ohms. So it's 5 ohms over the total amount of ohms, which is 20 ohms, times the voltage being shared, which is 20 volts. So that gives you 5 volts. So 5 volts for him and 15 volts for him. All right, I hope that makes sense. Let's try another one. Let's say we had 30 volts there. And he gets 5 ohms again. And this time he has 10 ohms, right? How much does A get in terms of voltage? Remember, more resistance, more voltage, less resistance, less voltage, right? So resistor A will get 5 ohms over the total voltage, which is 15 ohms, times 30, which then gives me 10 volts. So 10 volts for A. And for resistor B, it's 10 ohms over total again. For B, it's 10 ohms over total, which is 15 ohms, times 30, which gives me 20 volts. And again, you see a combination of 10 volts plus 20 volts is 30 volts. And then obviously in a scenario then like this, let's look at this, where he's an only child, right? He's an only child. Like I wish I was. And I love my brother. Right, if he has 40 volts, as an only child, he will inherit 40 volts. I hope that makes perfect sense, right? So a parent will inherit to his children, all right? Not too hard to appreciate, right? Now, let's think about items in parallel. Oh, that's really important now. Let's come back to our scenario here. If this has 30 volts and he has 10 volts and he has 20 volts, and I then connect another circuit in parallel here, items in parallel have the same voltage. Pause to reflect on what I've just said. Items in parallel have the same voltage, right? So if he's got 10 volts, he will also have 10 volts. And if I put another item in parallel, he will too will have 10 volts. And another item in parallel, he will also have 10 volts. Do you see that? So items in parallel always have the same voltage. What if I broke it here? What if I broke it some here? Find my eraser. Yeah, there we go. And I connected it like this. He would have 30 volts. And if I connected another item in parallel there, he too would have 30 volts, right? Does it make sense? So I often say to the kids, when you are doing circuits, first maybe focus on a sort of principal circuit. You see I've highlighted there? That's the principal circuit. And in the principal circuit, the number of children, what the children inherit should equal to what the parent has, isn't it? To what the parent has, right? So focus on the principal circuit like I've highlighted. And remember, anything in parallel, items in parallel, will just have the same voltage. All right, I hope you've understood that. Let's move on. From voltage, we're going to discuss current. All right, we're going to discuss current. Now, back to our circuit. Now imagine a scenario where I had, say, 10 amps flowing through the circuit. Notice we're no longer discussing voltage, we're discussing current, right? And because current is measured in amps. I like to think of amps like ants. So what's actually moving through these wires, right? What's actually moving through these wires is actually current, right? In a sense. Although in theory, we know electrons moving in the opposite direction, but that's a discussion for another day. But what's moving through the wires is current, right? What's moving through the wires is current. I'll say it for the 5th time so you don't forget it. What's moving through the wires is current, not voltage. Voltage is not moving, but what is actually flowing through the wires is current. So think of little ants, right, running through the wires, right? So imagine, for example, 10 ants or amps get to this junction here. Then they're like, all right, we need to, decide which direction we're going in. So some ants will go left and some amps will come down. If, for example, 6 amps come down, it means 4 amps will go left. So resistor A will get 4 amps. When they're done with him, these amps will flow to resistor B, and he will also get 4 amps. You see that? Because they're just flowing through him, right? Like ants running through, I don't know, a little tunnel or whatever, right? Ant tunnel. All right. So 4 amps flow through A, and then 4 amps get to B, and when they're done with B, they proceed to the junction. Whereas how many ants or amps flow downwards? And you have 6 amps flowing downwards, and when they're done with there, they will flow through. And then what happens when they get to the junction here? They combine, and you're going to have 10 amps now. You're going to have 10 amps going up. I hope that makes sense, right? And of course, they kind of flow back to the cell. Right. So what happens to current? Current splits. Current does what? It splits. But does current split evenly? Well, in the example above, we saw it did not split evenly, right? Because many kids kind of assume that the split will be equal, and that's not true. But of course, sometimes they do test you on whether the split will be equal. And do you know when they split equally? When they have the same resistance. So for example, if there was 6 ohms of resistance there and 6 ohms of resistance there, and then of course as the current flows, it will, let's say I have 10 amps here, in that case it will split equally. So if this resistance at A is equal to the resistance at B, then they do split equally. So you then have 5 amps there and 5 amps there. Does it make sense? And then of course they'll combine and become 10 again. I hope that makes sense. So basically, what determines how the current splits? It's the resistance. However, it does not split equally. When does it split equally? When does the current split equally at a junction? It will only happen when the resistances are the same. So they have to be identical items. I hope that makes perfect sense to you. So far that is current. Now let's discuss resistance. Alright, let's discuss resistance. What do I know about resistance? Well, back to our circuit. So you can have resistors in series to each other, right? Resistance, of course, as you've discerned so far, is measured in ohms. You could have maybe 3 ohms there and 4 ohms there. When resistance is in series, as in the example here, you just add them up. So 3 plus 4 makes 7 ohms. All right, so resistance in series is easy. If they are in parallel, now it's a little bit more interesting. 3 ohms, 4 ohms, and what's the combined resistance here? Well, the formula to use when they are in parallel, resistance in parallel, the formula to use here is resistance in parallel is equal to R1 times R2 divided by R1 plus R2. Oh, that's interesting, right? So in this case, it would be 3 times 4 over 3 plus 4. And here's an interesting thing. So you've got 12 over 7. And I think that gives you approximately, my calculator here. Where's the calculator when you need it? That gives you approximately 1.6, I think. Yeah, 1.7. So it's approximately 1.7 ohms, right? Notice what happens when you put items in parallel. When you put resistors in parallel, the combined resistance becomes much smaller. Do you see that? It's smaller than 3, it's smaller than 4. The combined resistance becomes much smaller, right? That's an interesting fact, right? So resistors in series, you just add them up. Resistors in parallel, what do? we can use this formula. But this only applies when there are two resistors, right? When there are two resistors. That's a quick formula to know when there are two resistors, which is what you principally get in your Igcse physics. All right. So, what have we learned? Voltage, like a family, isn't it, right? If the parent has 25 volts and this child gets 15 volts, this child will get 10 volts. What determines how much the voltage they get? It's kind of like resistance, isn't it? If you have more resistance like the bigger brother, you get more voltage. If you have less resistance like the smaller brother, you'll get a smaller inheritance of voltage. Does it make sense? But of course, when items are in parallel, they have the same voltage. So if this is 15 volts and it's in parallel to him, he will also have 15 volts. Noteworthy. And of course, we also discussed was current. We discussed current. And what does current do? Current is what's flowing through the wires, and it flows from the long side. Please note, from the positive side, current is flowing from the long side and it's flowing through the wires. When it gets to a junction, the current has two options. It has to split, isn't it? And does it split equally? It does not. It splits in an inverse proportion to resistance, but that's for another day. But basically, it will only split equally if the resistances are the same, right? So in this case, if, for example, 2 amps goes this way, assuming at maybe 10 amps, 8 amps will go downwards. So he will get 2. When they're finished with him, they will move on to this chap, and he will also get 2. And when they're finished, the 2 amps will go to the end, right? They'll go to the end, and the 8 amps will come here, and they'll join back and become 10 amps again. All right, that makes sense. And of course, resistances, which are measured in ohms, we said when they're in series, 3 ohms and 5 ohms makes 8 ohms in series. And when they are in parallel, 3 ohms and 5 ohms in parallel is 3 times 5 over 3 plus 5 to get the resistance in parallel. All right, I hope that makes sense. So far, so good. Let's try 1 or 2 questions. Don't want to make this video too long. It's already longer than I anticipated. All right, let's try 1 or 2 questions, right? So say, for example, you have a circuit like this. I'm drawing, this is 7 ohms, right? And this is 8 ohms, right? And there are 2 amps flowing through there, right? You're asked to work out what is the voltage here and the voltage here. Before that, let's just recap on some important formulae we know. So in terms of electricity formula, there's only 5, I would say, in this section before we get into transformers. And the formula you need to know are V is equal to IR, where V is the voltage, I is the current, and R is the resistance, right? V is equal to IR. There is P for power is equal to IV. I again is current, V is voltage, so PIV, right? PIV. P is power. P is power. Don't forget, I is current, and V is obviously voltage. Okay, PIV. IVT, energy is equal to VIT. E is energy. V voltage, I current, T time. This time has been seconds. Quit is another one we're going to discuss. Quit. Q is quantity of charge. Quantity of charge. Charge. I current, T time again. And and resistors in parallel, which we've discussed, right? Resistors in parallel is equal to R1 times R2 over R1 plus R2. We've discussed that one. All right. So far, what we need most is V is equal to IR for now. V is equal to IR. We'll come to these in a future date. So this is the learning formula for now. All right. So you've got a current flowing there of 2 amps. Let's come to this example. And you need to require to work out V1. So, and then also V total from the parent. All right. So I could say here, how do I get V1? I know the resistance and I know the current. So since there's no split in the junction, 2 amps are flowing here, right? So V is equal to IR, I being the current 2, R being the resistance of 7, that gives me 14 volts. V2 is the same formula, I times R, and again you see the same current, so the current continues to flow, there's no split, so 2 amps of current still continues to flow, right? And will be experienced by him too. So the current is 2, the resistance is 8, that gives me 16 volts. So 16 volts for him. So if this child has 14 and this child has 16 volts, how much does the parent have? That should be obvious. These 2 children have inherited from their parents, so their parent becomes 30 volts, a combination of the 14 and the 16. Makes lots of sense, yeah? Let's try another example. So say, for example, you had something like this. Like that. This is 6 ohms, right? And you're required to work out the current, I1 here. We don't know the current here. We're told that this is 3 amps. They're required to work out the resistance there and the voltage here. And we're told that this is 18 volts. And this current is I. Unknown. Another current we need to find. All right. I'm going to focus first on my main circuit. Focus on my main circuit. I'm going to change the color of my highlighter. Right, let's focus on the main circuit. Do you see my main circuit there? In the main circuit, if my parent has 18 volts, how many children in the main circuit? Only 1 child in the main circuit, which means that if the parent is 18, the 1 child inherits how many volts? How many volts does he inherit? He inherits 18 volts. As you can see, right? He inherits 18 volts. Now, is it hard for me to figure out what this parallel guy will inherit? Is it hard for me to figure out what this parallel guy will inherit? Well, I know items in parallel have the same voltage, so I know V2 has to be 18 volts too. Does that make sense? All right, so now I've solved for V2. Let's think further. Can I work out the current at A? I'm calling this A. Can I work out the current at A? If V is equal to IR, the voltage at A is equal to the current at A times the resistance at A. You understand that, right? So what is the voltage at A? 18. I'm looking for the current at A, which is I1, and the resistance at A is 6, and therefore the current at A is 3 amps. So I know I1 is 3 amps. Does it make sense? So now, focusing now on the split, right? The split happens here. There's a split here, isn't there? Some current went that way and some current went that way. But I can see 3 amps went that way and 3 amps went that way, which means that the main current is how much? The main current would have been 6 amps before the split. I hope that makes perfect sense, yeah? All right, young people, I hope this helps, an introduction to circuits, and be sure to pay attention to the next video. So it's a bit long, but hope that helps.